Sometimes in science, we've got to deal with very large or very small numbers. For example, let's write down the mass of one water molecule. I have to be very careful about counting zeros when I write this mass down because it's so small. 3, 6, 9, 12, 15, 18, 19, 20, 21, 22, 23. It went off the edge. That's how many grams. I can't even fit the whole thing on there. Now, I had to count all those zeros pretty carefully. So it'd be very easy for me to make a mistake when I was writing down a number like that. So that's not a good way to write down very small numbers. If I've got a very big number, it's the same problem. If I was going to tell you how many water molecules were in a drop of rain, it would be something like a 2 with 21 zeros after it. That would be how many molecules are there. So I don't want to be counting all those zeros all the time because it's very easy to make a mistake and miscount. So what do? Scientific notation lets us get away with not writing down all those zeros. Suppose I had a number like 1,000,000. 1,000,000 is a 1 with 6 zeros after it. Well, in scientific notation, I can write that down as 10 to the 6th power. Now, you can think of it like this. The exponent tells you the number of zeros that you write after the 1. That's one way to think about it. The actually mathematically correct way to think about it is that this is 10 times itself 6 times. All of these are the same number. So what if I had 3 million? I could write 3 million down like that, or I could write it as 3 times 1 million. And that's scientific notation. Now, using powers of 10. So you have a power of 10, and you have a number here between 1 and 10. It's never 10 there. It can be 9.99999 or something like that. But it's less than 10 and it's 1 or greater in there. So you take the number and all those zeros then get encoded as a power of 10. Let's practice this a little bit. What if you had 300? What would that be in scientific notation? I can do it pretty quick if there's zeros there because I can just count how many zeros come after the 3. And that's my exponent. That works out kind of nice. But what if I had something like this? 197, and I want to put that in scientific notation. Well, I have to make this into a number that's between 1 and 10. So what I'll do is, the decimal point was right here, right? So I'll bounce it 2 places to get a number between 1 and 10. Then I would have 1.97. And since I bounced it 2 places to the left, that's what the number would be in scientific notation. It's the number of places the decimal point moved. Now I'm going to have you practice that in the problem below.